right, ladies, you should have worksheet 712 in front of you to take these notes, and you also should probably have at least 2 or maybe 3 colors of pen or pencil, not fat markers, but a bright pen or a pencil, okay? All right, the first thing, what we're going to be talking about today is looking at the steepness of the line. And so the first thing we're going to do is graph a couple of lines. And what I've done is I've given us 2 lines to graph. Both of them have the same y-intercept. Our y-intercept on both of these lines is 3. So we're going to start on the y-axis at 3. But they have 2 different slopes. On y1, we have a slope of 1, that number right there. And on y2, we have a slope of 2, this number right here. Okay? Remember that is a slope of 2 over 1 and a slope of 1 over 1. So I'm going to graph first y1, and I'm going to do that in one color. Start at this 3, and rise 1, then front 1. Fill up the graph paper. Nice straight line, and label it with the y1. I'm going to go a different color. You don't actually have to use different colors if you don't want to. I'm going to start at the same place. I'm still starting as a y-intercept of 3, but this time my rise is going to be up 2 and over 1. And again, I want to fill up the graph paper right there in both directions. Nice and straight. We connect those. And I'm going to label that y2. And then you can see, once they're on the graph paper, that y2 is more steep. More steep than y1. You can tell that it would be more difficult to walk up that hill, up the red one than the blue one. Okay? All right, now we're going to add a third line to this, y3. And notice that I've given it the same y-intercept, so I'm going to start it at 3. But this time, my slope is 1/2. Okay? So I'm going to start at my y-intercept and do a rise of 1 and a run of 2. And you're going to fill up your graph paper with that slope, or in both directions. And there's y3. Okay? In comparison to the other 2, we can see that y3 is the least steep of all of these lines. Okay? And down here at the bottom, what I want to do is make a list. I want to put the most steep first. And I want to end with the least steep. Let's put them in order. So the most steep for this problem was y2. It was 2x plus 3. The least steep was y3, which was 1/2x plus 3. And the one that was between them was y1, which was 1x plus 3. I'm going to put that 1 there so you can see the slope. Our goal is to be able to answer the question, which is the most steep, without having to draw the graph. So to do that, we're going to compare the numbers that are the slope. Okay? The slope for y2 is 2. The slope for y1 is 1. And the slope for y3 is 1/2. By looking at the size of the slope, we can tell which line is the most steep. So basically, larger slope. It's like a slap. Larger slope means steeper line. That's only true if the slopes are positive. I have to make a slight adjustment when the slopes are negative. So bigger slope, steeper line. It's pretty simple. Okay. On the next page, we're going to take a look at negative slopes. Remember, negative slopes have to go downhill when you graph them. Make sure they go downhill. Again, just to make this easier, I have made my y-intercept 3 for all of them. So I'm going to have that same starting point. On the first graph, on y1, my slope is -1. On the second graph, my slope is -2. And to help you remember your rise and your run, sometimes it's nice to put that over 1. Okay? I'm going to graph y1 first with my blue pen, starting at 3. And I'm going to make sure that when I rise 1, I run to the left so they end up with a negative slope. Rise 1 and run to the left. Fall 1 or drop 1 and run to the right. I get a nice straight line. I label it y1. Get a different color pen, and I'm going to graph y2. Again, starting at b equals 3, and I'm going to rise 2 And again, run to the left, but only run one. Rise 2 and run 1. And put as many points on the graph as you can, moving in both directions. There's my y2. And you can tell by looking at this that y2 is more steep. You can say more steep, or you can say steeper. All right? And we are again going to put in a third line, also having on y-intercept of 3, so I'll start on the 3. And this time my slope is -1/2. Start on the 3, I'm going to rise 1 and run 2. Make sure you're keeping that slope negative. Make sure you double check yours and that it's looking like mine. If not, stop and erase it and fix your picture. Okay? And once again, just like on the first page, this third graph that I drew, y3 is the least steep. Okay? So let's take these three and put them all in order from the most steep to the least steep. And the most steep was y2. Negative 2x plus 3. And the least steep was y3. And the one in the middle was y1. And again, we would like to be able to answer this question without having to draw the graph every time. So we're going to take a look at the slopes to tell us which is the most steep. Okay, now, which of those numbers is actually bigger? Well, -1.5 is really a bigger number than -2. You don't have to draw this number line, but if you have this number line, and you have -1 and -2, -1/2, this number is actually the biggest number. But when we're considering slope, we need to just sort of ignore the negative. So kind of ignore the negative. Well, the negative, let's do it this way. The negative tells you to go that the line decreases. It means you draw it downhill, okay? But the size of the slope, that is, look at the number without, you know that abbreviation without the negative, it tells you negative. Without the negative, it tells you the steepness. So when you look at those numbers, you want to kind of think that the size of that slope is 2, and the size of that slope is 1, and the size of this slope is 1/2. This is called absolute value. We don't see that word before. So when we want to look at negative slopes, we just ignore the negative in order to tell which is the steepest. The negative tells us it goes downhill, but the size of it tells us which one is the most steep. All right? So let's try this. We're going to practice this without drawing any graphs by looking at a handful of different equations that we might come up with. We're going to look at all 4 of these equations and pick which one is the most steep by looking only at the slope. I'm going to put a 1 in there. Only at the slope. So my slope here is 2. My slope here is 4. My slope is 1. And my slope is 6. So most steep, y4. Next most steep, y2, followed by y1, and the least steep of these 4 choices is y3. Okay? When you look at negative slopes, the negative will tell you that they go downhill. But if you just ignore the negative and only look at the numerical part, the size of the slope, then that's what you're going to use to pick the most steep. And they're going to be exactly the same order, even though the slopes are negative. It'll just be steep going downhill instead of steep going uphill. So the most steep is still y4, then y2, then y1, and then y3. Now, real-life problems. People that actually work with equations of lines are going to have slopes that are not always just nice, neat little integers, 1 and 6 and -2. Sometimes they're decimals. Okay, so that's okay. We can compare decimals. Which of these 3 slopes is the biggest number? 1.45, 1.65, or 1.09? 1.65 is the biggest, so the most steep is going to be y2. The next biggest will be y1, and the least steep of these choices will be y3. Sometimes our slopes are fractions. Sometimes you can compare fractions just as fractions, but sometimes it's a little bit easier if you change it to a decimal. So you type in your calculator 1 divided by 2 and get 0.5. Actually, that one y'all probably have memorized. 3 divided by 4, you might remember that one. What is 3/4 as a decimal? If you don't remember, type in 3 divided by 4. And not too many people have 2/5 memorized, so you might want to type in 2 divided by 5 and get 0.4. And you may also remember that when you want to compare decimals, you want to have the same number of decimal places so that you don't think this is a 5 and this is a 75. You need 2 decimal places. Okay, this is a 0.50, 0.75, and 0.10. Okay, so what's the most steep? 0.75, so that's y2. And the next one would be 0.50, so that's y1. And the least steep would be y2. And the last one is just to, again, put negatives in one more time and maybe some slightly larger slopes. Which of these three, all of these go downhill, that's what the negative tells us. But you want to look at the value, the 22, the 17, and that invisible 1 to decide most steep. And this one's already in order. The most steep is going to be y1, it'll be very steep downhill, then y2, and then y3. Okay? Now, how I'm actually going to have you show me that you recognize this is by giving you a graph that's on a piece of, on an axis that doesn't have graph paper behind it. There's no grid on it, okay? But it's really not hard, and it's really pretty quick, so these will go very fast, okay? We're going to look at the two equations, y1 and y2. We're going to note that the slope is 3 and 1, and decide which is the most steep. And maybe label it. The most steep is y1. You're going to look at the 2 lines that are available. Which one of the 2 lines there is the most steep? I'm going to trace it. This one is the most steep, so I'm going to put a y1 there, and that means this one is the least steep, y2. That's pretty much all we're going to be doing, okay, for right now, right? You'll also notice that I've made a lot of these have the same y-intercept for right now, okay? For number 2, the most steep, is it the one with the slope of 3 or the one with the slope of 5? It's the one with the slope of 5. These two are both very steep. But the most steep is the one that starts here and ends up on the inside right there. So that one's y2, and the one over here is y1. Okay, these two have y-intercepts that are down below the origin. But again, we're looking at slopes. That's all we're looking at. So the slope here is 1/2, and the slope here is 1. Which is bigger, 1 or 1/2? 1/2 is bigger, so this one's the most steep. Identify which line is the most steep, and label that with y2, and label the other one with y1. And number 4, we have a slope of 1/2 and 3/4. You might think about the decimals. That helps you. Which one is bigger, 3/4 or 1/2? And the bigger one here is 3/4. And the steeper line is the one I'm tracing in blue. So that one's y2, and the least steep one is y1. Okay. If you want to right now, you could turn off the, well, no, we've got negative slopes, so let's do those also. Okay, number 5, y1 and y2. There's no y-intercept here, so just as an aside, I would like to point out that that's +0. That's why both of them go through the origin. Which is the most steep? This one goes with that one. y2, y1. And I can't even really see the y-intercept over here. For some reason, I decided to stop drawing my line. That doesn't seem like a very good idea, but I did. I still need to get the one that is the most steep. This one, I've got negatives. They go downhill. But you want to look at the 0.03 and the 0.125. Get the same number of decimal places in them, so they have 3. And then you can compare 30 to 125, and this one is the most steep. Look at those 2 lines. Which one is more steep? It's this one. So this is y2, and the top one is y1. Number 7, again, see it's going to the origin here because there's a understood. You see +0 right there, also a number 8. Which one is more steep? Don't think about the negatives. The negatives make it go down. You want to think about the 3 and the 1. So the most steep is the first one. Look at your picture. The most steep is this one. I'm going to label at the bottom this time. It doesn't matter if you label them at the top or at the bottom. Number 8. They're both negative slopes. I want to think about the number without the negative. That's a 1 and a 1/2. Which number is bigger? 1 is bigger, so y1 is the most steep. This line that I'm tracing in blue is the most steep, and the other one is y2. If you wanted to pause and try 9 and 10, you could do that. Hit pause and try 9 and 10, and then turn it back on and see if you get it right. Okay? Let's look. Here's -50, downhill with a size of 50, -15, downhill with a size of 15. 50 is bigger, so y1 is the most steep. This line is the most steep. I'm not going to label it. If you label it up here, I won't know which one it goes with, so don't label it up there at the top. This time I want to definitely label it down at the bottom, and that one's y2. And both positive slopes here, these have the same numbers on them, 0.361, 0.145. y2 is the most steep, and y1 is the least steep. Okay? All right. So that's slope. The next thing we're going to do is compare graphs by y-intercept. So when you look at all the problems on this page, you're going to see that every single line has the same slope. There's a word for that. Can you look at those lines and tell what that word is? What do we call these lines when they never cross or never intersect each other? They are parallel and have the same slope. So how can you tell the lines apart if they have the same slope? Well, you can look at the y-intercept. This y-intercept is +4, and this y-intercept is -4. So there we have 2 y-intercepts. Which one of those has to be positive? This one. Which one has to be negative? This one. So I can label them by comparing their y-intercepts. On number 12, they both have a slope of -1. They're parallel. They both go downhill. This has a slope of 4. This has a slope of 2. So here's my 2 y-intercepts. If that's one of those is 2 and the other one is 4, the 2 has to be the lower one. The 4 has to be the higher one. So this one's y1 and this one's y2. It doesn't matter how big or small the numbers are. We've got no grid on this graph paper. We're just looking at comparisons, bigger, smaller, positive, negative. This has a positive y-intercept. This has a negative y-intercept. These are my 2 y-intercepts. This one's positive. This one is negative. So this one must be y1, and the lower one must be y2. And the last one, these are little teeny tiny numbers. People can deal with science to deal with great big numbers, like if they're dealing with stars and the universe. And they also deal with little bitty numbers if they're looking at atoms, okay, or bacteria. Okay, these have the same slope, they're parallel. So which one of these, they're both negative. Okay, negative numbers are always a little trickier than positive numbers. Ignore the negative for a minute. Which one is bigger? Well, this one's bigger, but since it's negative, it must be lower. 1.628 is a bigger number than 1.035, and when you put those on the negative axis, they flip directions. So this one's going to start lower here. This one's y2, and this one's y1. Okay. All right, and the last comparison we have is horizontal and vertical lines. All right, these 2 lines are horizontal. The x and y axis are the ones with the arrows. Okay, so this is a horizontal line through 3, and this is through 3. This is a horizontal line through -2, y1, y2. This horizontal line goes through 3, and this one goes through 5. Here's the 2 places. One of those is 3, one of them is 5. The 3 has to be the lower one, the 5 has to be the higher one. So the top one's y2, and the bottom one's y1. Okay, I have to do a -5 and a -2. Here they are. If you were to write numbers on that number line, you would get to -2 from the origin. You would get to -2 before you would get to -5. So the bottom one is y1, the top one is y2. And I like it when one's positive and one's negative because then I don't have to think very hard. The top one is y1, and the bottom one is y2. That's horizontal lines. And then we have vertical lines, the same thing, except the lines are going up and down. Again, the ones with the arrows are the x and y axis. This time they're not going to cross the y-axis, they're going to cross the x-axis. It's the only time we do the x-axis. Crossing the x-axis really is when they're vertical. So one of them crosses at 3, the other one crosses at 2, that at -2, that has to be this way. x1, x2. Both of these are positive, but one crosses at 3, one crosses at 5. Which one of those has to be 3? Which one has to be 5? The first one 3, the second one 5. So this is x1, x2. These are both negative, -2 and -5. If you're start at the origin and you head this direction, you get to -2 before you get to -5. So this one is x2, this one is x1. And again, I love it when one of them is positive and one of them is negative, because those are the easiest ones to figure out. I don't have to think very hard. Okay? And the last one is what if one's horizontal and one's vertical. And remember, these are easy to get backwards. So we had a whole worksheet on this before. Just make sure you know which one you're doing. Okay? If it's x equals, it's vertical. If it's y equals, it's horizontal. And then remember that the way I've drawn this is the ones with the axes have the arrows on them. So the vertical line is this one, x1, and the horizontal line is y1. Okay? The horizontal line, y1, the vertical line, x1. For some reason, on the last one, I made both of them vertical again. Oh, this is the same problem we already did. Looks like I forgot to get rid of it when I cut and pasted it. But just for the fun of it, I'll put these two here. Again, this one x2 and x1. All right. The homework consists of two things. One, homework 1, which is 2 pages long. It's only 5 problems. And then homework 2, which is also 2 pages long. I do not want you to do homework 2. I only want you to do homework 1. It is a tiny bit trickier, because instead of asking you to compare 2 lines, I'm asking you to compare 4 lines. You need to compare positive slopes, negative slopes, positive y-intercepts, and negative y-intercepts. I'm going to do one for you. Just going to do a little bit. This has a positive slope. So it's got to be either this one or this one. That's the only two it can be. It also has a positive y-intercept. This one has a positive, this one has a negative, so it's not this line. It must be that line. Okay? You are comparing positive slopes, negative slopes, steep lines to less steep lines, positive y-intercepts to negative y-intercepts, higher y-intercepts to lower y-intercepts, and then a little bit further on, I think on the second page, horizontal and vertical lines. Okay? All right, that's it.